It's widely accepted and agreed upon that people learn differently. Certain methods, like audio, tactile, and visual, may help a student better remember or recall a concept. We wanted to test whether an added visual aid, flashes of respective colors, would help a student remember a list of colors being read aloud in an audio recording. Our statistical question is there a significant difference between the mean memory recall scores of students who only listened to the audio list of colors and the mean memory recall scores of students who also had added flashes of the respective colors in a video? We had two treatments, Form 1, which only contained the audio, and Form 2, which contained both the audio and 1-second flashes of the corresponding color. After creating the videos using a video editing program, a set color bank from Wikipedia, and a voice recording done to a metronome pronouncing each color in a second, we asked friends and acquaintances to try our experiment. Writing down 1 on 30 slips of paper and 2 on another 30 slips of paper, we mixed the slips together in a plastic bag and through the PAT method randomly assigned our subjects to Form 1 or Form 2. This ensured that there were exactly the same amount of people per treatment. For each treatment, they were told to listen and watch the respective videos, only audio or audio with flashes of color. We made sure that they did not know what the other treatments were by scattering the subjects around the room, requiring that they listen and watch the video with earphones, and not providing further context about the experiment. Here is our data table for all the raw scores. The mean for Form 1, only audio, is 15.4, and the standard deviation is 3.24. The mean for Form 2 with flashes of color is 14.6, and the standard deviation is 3.01.
Now for the data analysis. Our two hypotheses are the null hypothesis is mean 2 minus mean 1 is equal to 0, and the alternate hypothesis is mean 2 minus mean 1 is greater than 0, where mean 1 is the true mean score of CCA students who received treatment 1, which was where the colors were only presented in audio form, and mean 2 is the true mean score of CCA students who received treatment 2, where the colors were presented in audio and visual form. Mean 2 minus mean 1 represents the true difference in means of the scores of the color memory recall test based on the two treatments as listed. We'll perform a 2-sample t-test, and checking our conditions, we randomly assigned our treatment so the random condition is met. Each sample has 30 people, which satisfies the central limit theorem as well. When we executed our calculations, we found the t-statistic to be 1.77 using the degrees of freedom of 29, and our p-value was 0.96. Because our p-value of 0.96 was way larger than our alpha confidence level of 0.05, we failed to reject our null hypothesis. So we do not have convincing evidence that the addition of a visual aid of flashing colors will increase the mean scores of a memory recall test of a list of colors when compared to the mean scores of a memory recall test where there is no visual aid provided. The process of creating and running our experiment went fairly smoothly. Collecting our data was simple, efficient, and quick. Because of the straightforward nature of our experiment, people didn't really require extra instruction either. Additionally, the videos themselves were easy to put together. A difficulty that we faced was choosing the color selection to be included in the videos. For example, when we searched up the color blue, we'd find many shades from like sky blue to navy blue and more. So we learned to be more specific with our colors, and we used the standard set of colors from Wikipedia. The most surprising part of our experiment was the results themselves. We initially predicted that watching the video would help students recall the colors that were mentioned better since they had both the auditory and the visual aid. But after getting a p-value of 0.96 with our initial test, we thought maybe the results would be significant in the other way. So our new significance test tested the hypotheses where the null hypothesis is equal to mean 2 minus mean 1, which is equal to 0, versus the alternate hypothesis, which is mean 2 minus mean 1 is less than 0, where mean 1 and mean 2 represent the same thing as the original significance test. Thus, our new p-value became 1 minus the old p-value, so 1 minus 0.96, which is equal to 0.04. Since 0.04 is less than the alpha level of 0.05, we rejected the null hypothesis. Therefore, we have convincing evidence that the addition of a visual aid of flashing colors will decrease the mean scores of a memory recall test of a list of colors when compared to the mean scores of a memory recall test where there's no visual aid provided. It's possible that the visual aids were distracting to the subjects. As some of the colors were uncommon, the subjects may have been more focused on learning about the actual colors than remembering all 20 colors that were stated. In conclusion, our hypothesis that visual aids would help people remember colors that were spoken to them was thoroughly trashed. We found instead that the visual supplement caused the performance of subjects to be lower than the auditory listeners by a significant amount.